So far we've seen relatively simple examples of the various development types that we can do in SAP HANA Extended Application Services. But now I think it would be helpful to look at an example that's a little bit more representative of the real world, and which combines together all the various development artifacts and techniques that we've seen so far. Let's begin by looking at the application itself. So what you're seeing here is a purchase order work list. The user interface is built in SAP UI5. We see that we have a relatively large amount of data, over 1 million purchase orders represented. And if I select a particular purchase order, you'll see that the item records get loaded for that associated purchase order. Now, these two tables are filled using an OData service, and one that's a little bit more complex than the one we saw in the earlier video series. This one allows us to model relationships between two different entities, between a purchase order header and a purchase order item. And then the user interface allows us to select a purchase order, and then it knows how to load the associated items. So one thing that I'll show you how to do in this example is how to build relationships into your OData object. Some of the other things that we have that are possible in here is this super search. So as I begin to type, I get an asynchronous call back to the server, and this is using a custom XSJS service. And unlike a traditional user interface where you might have separate search fields, separate input fields for searching on company name, city, category, product name, and so forth, we do all of the searches together, and then we federate the results into one response. So when we look at the custom XSJS service, you'll see how it's selecting from multiple tables and views, and then pulling all the results together into one to provide a more user-friendly experience. And for instance, here we can then narrow our list down to a smaller set of items. Let's just go ahead and reload with all our purchase orders, though. Some of the other unique features that we have here, we have the ability to update data as well. HANA and HANA Extended Application Services isn't just for reporting of data, but does have full transactional capabilities. For instance, I have an approved purchase order, and maybe I want to come in here and now reject this purchase order. You get a confirmation that you really do want to reject it, and then the update is performed and the data is refreshed. So we have a couple things happening there. We have validation logic that is written in XSJS to check all the statuses to make sure that a particular PO can be accepted or rejected based upon the values of its other statuses. And then calls to the database to perform the necessary updates or inserts or deletes in the database. And that's all made available via XSJS. One of the other things that we can do here is we talked about one of the things you could possibly want to use server-side JavaScript or XSJS for is for a custom body. And that's how we can do our export to Excel. We want to export all the records to Excel. Well, that requires us to create a text tab delimited format and to send it back as though it's an attachment instead of in the main body. Well, we're able to do that thanks to the fact that server-side JavaScript gives us complete access to the request, the response object, and we can do custom bodies. So this is another example of why you might want to use the full capabilities of server-side JavaScript in addition to using OData in other situations. And finally, one last thing that we have in this particular application is where we're really leveraging the power of HANA. We have an analytic report built into our transactional application where we can take all 1.1 million records and we can do a select sum on the currencies and group by a particular criteria. So our group by is dynamic, there's no pre-built aggregates, and furthermore we use a variety of different currencies in our data. Therefore we have to perform currency conversions so that everything's converted to a common currency before we can do a summarization. And here we're leveraging the power of HANA because we've built an analytic view that contains the currency conversion and the dynamic group by capabilities, but then we're calling this from XSJS and exposing it as a lightweight service to the user interface, and then we can quickly build a nice SAP UI5 dynamic HTML chart based upon this data. So this is really an excellent example of the kinds of things that we can do with SAP HANA Extended Application Services, combining the transactional world, the analytic world, and exposing it all to the user interface in a very lightweight but very user-friendly manner. Now let's see how this application was built. So returning to HANA Studio, you can see I have two new projects here. One is an XS project, and the other is my SAP UI5 project for my user interface. And if we look at our OData services, we do have two different OData services. One is very similar to the simple example that we saw in the earlier video. The only difference is that it uses a view instead of a table. So this is using an attribute view. And the attribute view does require that you add the addition keys. An OData service has to know what the data keys are. And if you use a table, we'll automatically read the database table keys and assume that those are the keys for the service. When you're processing a view, the system can't make an assumption as to what keys you want, so you do have to specify them directly in the service definition. Now, this is the more complex OData example that I wanted to show you, and it represents the source of this relationship that we saw in the user interface between the header, the purchase order header data, and the purchase order item data. As you see here, we are using two different attribute views. One is for the header data, and the other is for the item data. We have to specify the keys in each of these situations because they're both views. But more importantly, we define that the PO header, or the PO work list, navigates to the PO item. So we are setting up a relationship between the two. And then this relationship is further explained via the association that the PO item has a principal, which is the PO header, and that the PO purchase order ID is really the key field between the two in which this relationship is created. So we define the initial relationship via this association, and then we have to give the cardinality of that relationship. So this is what we have in this line: multiplicity 1, dependent PO items, multiplicity 0, star. That basically means that the header has a the header has a one-to-many relationship to the items, that we can have multiple items associated to a single purchase order header, which makes sense if you think about the logical relationship in the business that the purchase order header has to the item. Next, we have the custom server-side JavaScript. And in this case, I've got two XSJS files. I decided to break up all the query operations, all the read-only operations into one service, and then all the update operations into another. Let's look at the query. And if I scroll all the way down, you see the entrance, and just like in our simpler example earlier, we have a URL parameter called CMD for command, but we do have multiple commands. So we have the filter command, which is how we're processing the search. We have the get order totals. That's how we are processing and building the chart for the analytic report. And then we have the download to Excel. If we look at each of these, the get filter is pretty simple. We want to take the input parameter of whatever the user has typed in, and then we want to perform a query on that across multiple tables. So for instance here we might do our first query across the business partner table, based upon company name, and we're using the where contains clause, and we built a dynamic value based upon the input criteria, whatever is typed into the input field, the search input field, and an asterisk, so we get a wildcard search. So you're seeing already here a little bit of how we can interact with the database, which we didn't do earlier in our simple XSJS example. There we were just doing multiplication, but we have a very ODBC or JDBC-like syntax for interacting with the database. Although certainly we don't have to pass through that kind of interface layer or transform the data. That's one of the advantages that the HANA Extended Application Services has, is its closeness to the database. It is inside the database, and therefore we have closer technical access to the data than what we would have otherwise, although we wanted to keep things from a programmer with the kinds of concepts that they understand, that you can still write SQL statements, you have prepared statements, we perform and execute on the query, and then we get a record set back. And in this case, we take the record set that returns from each of our queries, and then we're building a simple JSON notation string at this point with the results. So basically getting attribute values in the category of the search, so that we can break them up and say that, okay, for all the values that came from company name, that's business partner company name. So we know which object, which table it originated from, and which field that originated from. That allows us to build that federated search result. And you see here we're just doing the same thing across multiple tables and multiple fields. Sometimes we use queries. I'm sorry, sometimes we use views to query against, and sometimes we're querying directly against the database tables. It just depends upon the complexity of what we're trying to retrieve. At the end, we want JSON returned in the body, so we just use JSON.stringify, and it will take our JSON notation string and turn it into something that we can pack into the response body. And we set the content type. Likewise, we can set headers as well, custom response headers. In this case, we're allowing access control allow origin star. That means that this service could be called from a different URL than what the service originates from. So if I had my web page was hosted from a different web server than being hosted directly by the HANA system, this would tell the browser that it's okay to allow that service to be called. So this is a security that sets the security standards for the browser. The get total orders isn't drastically different. In this case, we take more input criteria. We're getting a couple of parameters from the user interface. We build a dynamic SQL statement. This is very dynamic because we're building in a dynamic group by, we're building in a dynamic where condition, all based upon what's chosen in the user interface. And in this case, we're saying select sum, the converted gross amount. So the currency conversion is actually embedded inside the definition of this analytic view. And then we have to pass in the currency as an input parameter to this analytic view. So you see we have not just the ability to interact with very basic SQL, but more advanced concepts for interacting with HANA-specific views. And we do the same thing here. We take the results and we turn them into a JSON response, and then we pass it back to the client side. Now the download to Excel gets a little more interesting, perhaps. We start with a basic SQL statement, just as before, but this time we're not using a JSON body. We want text tab delimited. So we're able to build up the text tab delimited stream along with column headers, and then because we have from server-side JavaScript complete control over the response object, we can set the content type to show that it's Excel, so that when the file opens, it knows to open Excel. We can also set the content disposition so to be treated as a file attachment instead of the main body, and replace the content that's already there. If we look at the update logic, this is very similar, except now we have the capability to, in here we're also updating or deleting some data. But this is an important part of of what XSJS can do as well. Of course, we still want to write our data-centric logic either inside HANA views or in SQL script, but neither of those situations are necessarily really good at performing simple if checks and things like that. They're designed for massively parallel processing, declarative logic on entire record sets. We want to work one record at a time, or in this case, we're doing some if checks to validate the current status of the purchase order before we perform any updates on it. XSJS is really well suited to performing that kind of logic before we even pass down into the lower level database layer. So that's all we're doing here. We're checking things like if the lifecycle status is closed, then you can't delete the purchase order. So we're doing various checks and then returning error messages if the statuses are not correct. And then finally, we're able to perform the update. And in this case, we can even issue a merge delta. So when you perform an update, HANA has some special techniques for column tables that we actually write into a row buffer, and then it would be merged asynchronously with the column table. But we're going ahead here and issuing the merge of the delta records as well. And I won't go through the second part because approving the PO is pretty much the same as rejecting it, just the status checks are different, but the overall process is basically the same.